Hello my Mudfossil friends. I am about today to explain the DNA reports which I've been talking about, and I've shown this before but people have missed it, so let's start from the beginning. I have 3 DNA reports that were certified as ancient human. One of them is this giant hand, and it's 36 inches wide. And what you're looking at here is not even the full palm. That's only a part of the palm. And then the fingers ran up here. And this was earlier when we found it. And there's been more things found since then, and we're going to examine them all. Now, the palm here is not here on site, only the bits and pieces, and I will show those, but I'm going to show this a little better. Now, what you're looking there is your own, just like your own palm. And it would be this hand. And if you laid your hand back like this, you have that same ridge running down your hand, and this is the palm that runs around your palm. And it's a different substance than the texture of your palm tissue. The body is very, very unique. Now, what you're going to see here, you see this silver stuff down here? That's silicon. The skin is dense with silicon. The pad is not. It's a different material from the pad. Look at over here. You see that? That's the pad that runs right around the side of your hand. Same thing right here. It's just strange, but that's what it is. And the silver is the silicon. And I noticed this when I started to separate it. The skin layer comes off. Really, the skin came off. And you've got the silicon that is below the clay layer of the skin. It had seeped down or whatever collected there. Let me see now. I have some other ones. Like I say, this was early when it was found. This. Oh, you see this? See the silver? That's all I can tell you. It's there now. And that was skin, and your skin is 50 times more dense in silicon than the rest of your body. And the grip skin specifically is very dense in silicon. The tissues in your body are very, very different in different places. Thin skin versus grip skin, your facial skin, the clays that make up the kaolin clays, your cornified skin, all different skins for different purposes. Now what you saw before was almost exactly this. It is the palm coming off of the long bones, the radius and the ulna, and that was the palm that ran around where the thumb comes off, and then where your other fingers, and it literally broke between the two, and then there was more of that, and then it ran out to where the fingers are. These are in between your fingers in the palm of your hand, and it was broken off right about here, almost identical to what you see there. All right, you saw the anatomical. There's the palm, which you saw before. There's that thing that runs down right in the middle of your hand too. That's where the thumb is. And this is where the little finger, the whole side here, this is only where it comes up to the edge of your hand, way over here. This is very, very, this is a small piece of the palm, really. It's huge, but it's small. Hello, my name is Roger Spur. I started Mudfossil University a couple of years back to announce the mudfossil discovery of human giants, really, and the flood that created these mud fossils. Now, I wrote a paper called Fascia Facilitated Fossilization, and fascia is the coating that coats all organs and body parts, and this is a mud fossil bone right here, and the coating of here is what's called fascia, and the ancients called it tunica. Now, if you look carefully, you're going to see that it actually almost wraps like a cloth around things. It's absolutely amazing. This is a lung that has that same fabric. You see how that fabric wraps around her? And it's actually eroded right here and started to fold back from where it wrapped around. And underneath that will be a red, bloody lung. As soon as that water works its way in, you will see that This part here is the red fleshy part, or the red bloody part. This part here is the tunica, and it's washed itself away. And this now is the inside of the lung. This coats all the mud fossils. That's fascia. Now, let's talk about fascia-facilitated fossilization. Salt water transitions bones. They're gone. They're absolutely gone. They've never found a bone in the saltwater wrecks. They're gone. And that's the difference between between this wet saltwater fossilization at about 7.2, 7.3, 7.0, right in that area. Your body is comfortable there. It says, I'm okay. I live in that stuff anyway. That's the water, and that's the pH I like. The bones say, no way. Salt water coming through here, washing through here, all these ions doing this, I'm gone. I'm out of here, and it's gone. Now, what else happens? Volatile organic compounds. Those are the chemicals that are in your cells and the gases and all these things, volatile things. They go into the solution in the water. They don't make it blow up and explode. They leak into the water. So what ends up? You end up with a fleshy matrix which likes salty wetness. They like it. It's fine. It's like, I live in that stuff. I'm a 7.2 guy. I'm just going around. I don't know what's going on. There's no more blood coming through, but I'm okay. So then what happens? Well, eventually the waters go away. The flesh dries as mud fossil body parts. The skin erodes as sand. And why do I say that? The skin has eroded as sand. Silicon is 50 times more dense in your skin. And it erodes off in these little beads of SiO2, silicon dioxide, because the water, H2O, invades it, and it just washes off. And there is a clay layer surrounding the earth that is deposited from this event that created these mud fossils. And it's a gray clay layer, which is all the kaolin clays added together. And that's what your flesh is. I mean, your skin is this kaolin clay with dense investment of silicon to make it really tough. All right, now, the skin erodes as sand. Red bloody flesh erodes as the clays. That's the clay. Red and bloody clay. All right? There's white clays too, which are your skin clays. And those are the kaolin clays. There's white and brown and yellow and green almost. They're the exact same colors as the body skins. Now, tendons are the tough things, and they're tough in your body too. They're not just tough when they dry out. They're tough, and they're made of limestone, CaCO3, and you are made of limestone, CaCO3 in your body right this very instant. It's in a flexible form, and it's all surrounded by these fascia. And that's what creates these hex fibers. When you see these gigantic hex fibers all around the earth, that's not from volcanism at all. That's from the fascia coating the individual hex. They call them fibrils. Look it up. They're tendon fibrils, and you'll see them. They're right. Anatomically, they're hex in your body. Now, and they stay apart when you're dead too, because they do the same job, living or dead. Doesn't matter to them. All right. Blood holds the metals. Blood holds the metals. That's where all the metals are. I've shown a zillion times in that opalized heart. It's all the metals floating around in your body. Those are the things that carry things in and out of your body to deliver and pick up products and deliver back out byproducts. And they eventually harden up, cause crystals and things to form. The metals bond to each other, and they make those fabulous looking facets and so forth. Fascia separates in death as it does in life. That's why you see these hex fibers. Now, that's all I can say about the process, other than the fact that they cover the earth. And they not only cover the earth, underneath somewhere, they cover the earth on the surface. So I'm saying this flood did not happen that long ago, because these things are all over the surface. And what they call them is erratics. They think these things were deposited by glaciers coming down and just all of a sudden dropping these things here and there. Well, they don't do that, first of all. The glaciers might have created moraines. I can go along with that. But they don't create erratics. They don't just all of a sudden go back and then just drop a big one here and then go back over here and drop another one there. That is not the way it works. All right. So, anyway, Adrian is going to present this as hopefully a coherent representation of what what must have happened, because we have the evidence to show that it's here. So at this point, we need to investigate, what is this all about? Were these things actually written to be true? And that is what Adrian is doing. And of course I'm doing it too, but he's actually going out in public and putting himself on the line, literally, because the people don't like to have this stuff change the way they've been talking about things. I mean, it's the way it is. People want to continue to feel that they had the answers, and then they're unquestionable, but now they have to be questioned. So that's just all we're doing. Not trying to hurt anybody's reputation or cause anybody any problems. These things exist. Let's take a look at them. We're going to go into all of these in a little bit of detail, not a whole lot, but before we do, I want to explain the process. All right, this might add a little bit of detail. When there's water in soils, they create what's called telluric currents, or they also call them spontaneous potentials. But the key to it is, as water moves in soils, it creates electricity. It moves electrons. It creates ions, and they move around, and they bond, and they do all kinds of things. That's what it's all about. And the telluric currents facilitate that bonding. And I have made mud fossils here, and it didn't take long. It only took 6 months or so to get them into a condition. When they dried out, they were pretty solid. Now, molecules and metals go into solution in these wet conditions, in these salty waters. So the molecules that are in the skin and the body and so forth, they get invaded, and instead of blowing up and exploding your body and turning it into a bloated mass that gets invaded by insects and so forth, it bleeds off into the water. Now, solvomorphism, solvo means solution, solvents, morphing, changing, with these little particles that invade, they change the tissues. So that's called solvomorphism. It comes in and invades the tissues with vanadium and chromium and copper and all kinds of things. And they want to go in there and find something to attach to. That is called carboxylation. And they are carboxylation of transition metals primarily, of organics, and they do this forever. Carboxylation transitions something forever. And the end product is this. They end up trying to get down to something similar to this, and then eventually it's diamonds. So carbon is the final product of sublimation. Sublimation is the product of boiling things off. You boil things off in your... when things cook off, they gas off, okay? When they gas off, they just go into vapors. Now, the last thing that will ever gas off is carbon. Carbon is the thing that does everything, and everything uses carbon to move, carboxylation. But carbon will override everybody else's life, because it doesn't go away until like 8,000 degrees, something like that, Fahrenheit. By that time, everything else is already gone. So the carbon is sitting there saying, hey, where'd everybody go? So I guess I'll turn it into a diamond. Now, heat, pressure, and time create the diamonds. And the reason for that is because it pushes all the other organic stuff out, the volatile organics. It's the heat, the pressure, and the time. And if you look up on the periodic chart, you can find out what the temperature they sublimate off at, and how the last vestige of life in them, and then they go, and then the next one comes up, and then the next one comes up, and the next one comes up, and carbon just happens to be top dog. So what does that do? Body chemistry and conditions are key to how these things preserve, but I'll be showing you in a minute how you end up with mud fossils. They have no bones, totally different product, and that's the key, is how the conditions that they're in, and that's the salty waters. Now, bone fossils are the exact opposite, absolute opposite. They just go away in these conditions of dryness, because everything rots away and explodes and festers, and then creatures start to consume it, and you end up with these little scraps of mineral, which is the bone, and maybe some little scraps of tendinous material, but mostly bone, because everything else is consumable. But in the water, totally different situation. When it came out of the water, it dried up and mineralized. Okay, this tells the story pretty good. You got your sandstone, which is the sand that has sedimentary stuff. Then you got mudstone, which is the red clays and the mud fossils. Then you got limestone, which is the tendinous material. As I said before, silicon, red, very dense in sand in your skin, which is eroded into sand. It's not so dense inside. Then you got, just quickly to go through them, this chemistry here, but it's not that important to see what it is. But you don't have a whole lot of calcium bleeding out of your skin, but you have a lot of it inside your body. This is what the chemistry is of your body. Now I'm going to show you another little clip. This really breaks it down probably better for the average person. Your mudstone is almost all clay. See it? Mud and mudstone, it's all clay. That's the red, fleshy, red stuff. Then slightly calcareous mudstone, that's where you got some inclusions in it. You start to get deeper into the tissues. Then it gets deeper and deeper and deeper. Marlstone, that's your organs and things. And then it gets all the way up into this area where it's almost all calcium carbonates, which is connective tissue, tendons primarily. So calcium CaCO3 up here, that's your limestone. And down here you've got your ferrous oxides, FeO2s and FeO3s, and your bloody, fleshy clay. Alright, I'm going to have to show this quick because there's something going wrong with my computer, but that's what happens in bone form. They leak out the blood and it turns black because the blue blood normally in you turns black when it comes out, but then we also have the red blood. And you know, they're very obvious and they're all over these things. You see them? Now I have what I have right here. This is live, and this one here was where I took a sample out from this this artery, and we submitted that for the DNA test. But I wasn't aware how little DNA there was in here, so this was not as strong as the other ones. Now, but that's this one right here. Whoops, let me get a little light on it. I'm going to show you this in a minute, a little bit better detail. But that's this a very eroded fingertip, and there's the blood vessels, and this is where the vessels blow out on the side. In the end, the arterial side. The vein side does not. It has little clamps. Now, this is the lung that was DNA tested. Now, this is a regular mat that's all over the lung. This is like what they call pleura or fascia, however you want to call it. Now, this is the area that we took the blood out of, way down here. And we drilled in here somewhere. I can't remember where, but there's a little pinhole we drilled in deep enough to get something. Anyway, it's down in this area. That's this right here, and we'll be looking at that in a minute. Now, so that's two that were DNA tested. Then I have a finger tip that is too big to have here, and that was DNA tested also as we dug deep in underneath the skin. So let's go take a look at things. Well, first of all, let's just take a look at the bonehead, because I show this all the time and I say this is a bonehead, and people, I mean, I know they can see it, but let's take a look at what the fabric of all these things are. They're all basically the same. You see they have these little tiny holes and spots and blood vessels here and there, you see? This is at the very head of the bone. They have different cavities. This is where the tendon goes in here. I'm sorry, the ligament connects in here. See all those little holes? There's little tiny ligament balls that go in there, and that straps across to the other side. It comes right out of this spot. I see it's darker. You're not going to be able to see that. Now, this is the only last bit of bone left in this whole bonehead. That's it right there. That's what's left. You see it? The rest, this is all transition. This is what they call source rock. That's turned into petroleum. This is the inside of bones, what they do. And it's got something, I don't know what it's got to do with, to be perfectly honest with you, but they do not, they don't don't just wash away, they turn into source rock. The petroleum industry knows this quite well because they're loaded with hydrocarbons, which is cell membranes. But that's what's left over of the bones, last vestige of bone. Alright, so let's look at it a little closer over on the bench. By the way, this is what, these are keratins or kerogens. They collect on the surface of grip skins. This is, let's see, what do we got up here? Alright, this is what you see a lot. That's the black is the vein. That's the artery, the red. And then the metals come out. And I should show you that. Hold on a second. Alright, this is a toe. This is this toe right here. I don't know if you'll be able to see it in the darkness, but here I'm going to look into the where the blood flows out of there and the gold comes out, because I talk about this all the time, but this is what happens. This little area over here, you see right there, I'm having a hard time focusing this and talking. It comes out of here. Most of this has been worn away, the gold, but there was a pretty good amount of it in the beginning, coming right out of it and then flowing out down into this area here, and it turned into flakes like, and then I just, you know, it's been years, it's been kicking around. And I have another one here, a gigantic one. Let's take a look at that. Alright, I've been talking about for a long time that there's metals coming out of here. This thing's probably going to crash, it looks like. Black and red. The red is the arterial. It flushes out the metals when it drains out, or if it gets collected in the foot, standing stuck in the mud, it collects in these arterial passageways. Alright, this lung right here was DNA tested, and it was dense with the DNA. We took it out of that red bloody spot there, and you know, fairly deep inside. I can't see the spot right here, but that's where the blood collects on these. Now, this little pattern right here is the pattern that these lungs make with the pleura that's surrounding them, and I believe it has something to do with the way these lobes lay on each other. Now, this fabric is the fabric that is fascia. That is what is the tunica, or whatever you want to call the wrapping of organs. And so that's the heart, I mean the lung. And right there, you see that little spot in the back there? That's the depression of the heart. This is a left lung, and it's certified human. Dense DNA. I talked to the people at the lab. Alright, so that's the lung. Now that was one of the things tested. This was the, well, the other one that I have here tested. You see that little black stain there on the front? That is the distal phalanges. And if you show that to any doctor, they'll understand it. Now, that's the vein and the artery there. The vein is on the right, and it does not blow out on the sides. Alright, the artery is on the left, and that blows out on the sides because there's no real restrictions to arteries, and it blows out on the end. Now, I took the blood from the very end of this, thinking that it was just easy, and I could see it was red, and I said, I just scrape a little out of there. I cleaned it up with a little bleach. I scraped in there, and it did not get very dense. It wasn't as dense as I thought. But the other ones I took right from the blood supplies. And the last one was this, which was skin. Let's see if I can show you the skin pattern. This is see the flash. You see those little stripe looking things? Those are the fingerprints from this. This part here is where it went right up on the side of a finger, where it meets the fingerprints. Those are the fingerprints. And there's little, I'm trying to get it in the right light here. If you can see, there's little dots. It's hard to get this here. There's little dots in the center of those stripes are the sweat pores, sweat glands. I have videos on it, but this came right off. Well, look at that. That's the best shot I got. I'm trying to illuminate it. You see the little dots? Oops, I can't judge it. Dot, dot, dot. You see that? Those are the sweat pores. And once we broke off the skin, you know, when I say we, I did it myself, to be honest with you. and it broke open here, and this is just a layer of skin. And then I went down inside the bulk of the finger and got some blood out of a arterial spot there. And I show this on the videos that's what's on this is there's bloody pores all over this. It's hard to see them, I'm sure, but if you could see real close, there's all kinds of little holes everywhere. That's what filters the blood through your body. Maybe this is a better shot. But anyway, the little tiny holes filter the blood through your body. This is the skin that you present to the earth, I mean to the world, and it is tough. There's the fingerprints right there. There's a sweat glands. That's the inside of the layer of this top layer of skin. That's how thick it is. All right, and so those were the 3 tested, and that one there was dense in DNA too. Now, what else did I find along with the hand? The hand had most of the stuff, the 36-inch hand. This is a knuckle. Let me get some of this out of the way. This is a knuckle right here. Now, what you're looking at, what I'm shining here, right here, is the fabric of the muscle that coats the bone ball. All right? That's a bone ball right here. All right, you see the bone ball? All right, and the other side of it is here, still wrapped with the muscle. This is where the tendinous material runs down along the side of the finger, and it breaks right here because that's the abrupt transition. And this is where the tendon heads down towards the hand, towards the end of the finger. So this is where the tendon slides down on the sides of the fingers, and that heads out to the end of the finger. They call that the distal side. Right? Now, so that I found. Then also this one here. This one here came from the other side, and is whoops, can you see that? Can you? Came from the other side, and it was complete. And completely wrapped up in its own tunica, just like a fingertip. And I broke the side off. This is the black blood side. You see? The other, and that's what went right there. Now, these colors here are not colors of mud or anything. These colors, that orangish looking stuff, see it? There and over here. That stuff is your, it's got something to do with tendinous material. And the other side of the finger, this is where the red blood goes in, and this is the end where the underneath there is what they call a apical tuft. That, you see some more of that orange looking stuff? It's got something to do with holding things in. You see the pattern here? That's a distal phalanges, and I have one, I'm sorry, that's an apical tuft. This is the distal phalanges finger. Those are the pads underneath. This cut out here, you see how perfect that cut is? That's where the tendons come into the side and they hold on. Very strange, exquisite architecture. Hold on. All right, this is what's in the end of these fingers. This is an apical tuft. What that means is that adheres right on the tip of that fingertip, wherever that went to. Anyway, it goes right on the tip of that finger, like a fingertip. The distal phalanges comes out like this. This sits on the end, and all of these tendon balls come out and they hook into these holes. They call them tuberosities. The little cavities, and this one here still has a ball attached, and it will have straps coming back, and that's what holds and gives you really very, very good, because I tell you, tendons are tough. So anyway, that is what is that's a fingertip. Now I believe all this stuff, it came right from the same hole, and one side was eroded. You can see this one here is eroded almost into nothing. That's blood, the rust color, that's from blood. This side here still has the flesh on it. See how that's the weave of muscle tissue. Alright, and that's what wraps around. This part here extends out. Hold on. Alright, let's look at this. I showed you that part that extends out. Let's see if we can find it here. Alright, here it is over here. It's right there. It comes, this is where it wraps around the bone ball, and you can see the muscle on the other side. And then that piece breaks right off here. That's what we're looking at right here. Back it out, you'll see it. Alright, match it up. It's actually backwards, but it goes this way. It's the same thing, only it's a different orientation. Muscle ball goes here, wraps around. This comes off just like this one. That comes off, and it breaks right here as it hits the red flesh. They just do that. They have what they call an abrupt transition, and we talked about that. All right, that's well, I've got a leg over here. I believe that's part of a leg. And again, once you put a little water on these, they take on a whole different appearance. This has been sitting around for years. All of them have been sitting around for years. This one, this came out of the ground. This leaked blood. This is a lung. And it leaked blood, absolutely unbelievable. Blobs of blood on every one of those red spots came out of this. And you see the different little patterns on this, the little keyhole looking things. That has something to do with fascia. Now you see how this turns into the black over here? That's where the transfer of oxygen is changing from where it sucks in the blood that needs oxygen, and then it gets oxygenated on this side. So that's I suppose that's enough for today. And there's one, and they come very big. Now this, I believe, is from the one that I showed the skin from. This particular bone is some kind of a long bone, I believe, and the distance around it is going to be enormous. This is just a little piece right here, right there. All right, that's the bone, and it is a bone. I looked at it very carefully in the microscope. All that's left is this of the bone in the inside. That's all that's left, is that little whitish looking color. Now, you see all the holes? That's what bones do. Bones are loaded with blood, really. That's why they turn into hydrocarbons. Now, that is a huge, huge, huge bone. And I believe that is from the thing that I showed with the huge, huge, huge skin. I'm finding these things, and they need, I mean, they should be looked at. That's what we're trying to have accomplished. And Adrian is accomplished at this. Understands this quite well. So, and anything he can't answer, I certainly can. I've been doing this a long time, so I've seen most everything. And I have most everything. And the things I have are kind of hard for anybody to actually believe. This is what happens to toes. See that? That is the last remnant of bone in that toe. See the bone? They turn into metals. Here's where the blood was. That's the red side of the blood. They have one side's red, one side's black. That's the red side. This is where the black side was. The black side hardens up and doesn't spit out. The red side spits out. And this is, I'm not sure what the metal is, but it's metals. And this is a toe. That's the guy's callus. He's had a lot of problems with calluses in those days. And this is what happens to toes. They turn into metals. And this would turn into just like the other one. You see, there's metals all over this thing. And then eventually they'll turn into something huge. I mean, the big ones will turn like this. That's a toe. I know you go, oh, it can't be a toe. It is a toe. And that's the toenail. And this side is the vein side that blew out, which never would. The vein sides never do, but this happened. This is what's cool about this. This is the callus. You see this? I'm going to get a little a better shot of this. Hold on, don't fall over. I'm okay, don't worry. All right, here we go. Now, you see that? That is the callus. And if you could see this, I mean, if you look at this in the well, let's see if you can see it. Maybe you will be able to see it. Sometimes the camera doesn't pick up any of this stuff. There's all kinds of metals and gold and things coming out of here, squeezing out from the callus. It's like a patch over the top where the gold and stuff normally spits out a little bit. Now, this patch is so tough that instead of it bleeding out through here, it bled out through the black side. Never happens. Never happens. This is because of this enormous callus on the guy's foot. Look, you see here? There's gold coming out of there all over the place, and gold and silver, and you can see it. I had it in a microscope, and then you can see down here. Remember, I showed you the stuff with the keratins and the kerogens. That's what this is, and this thing is heavy. This baby's loaded with metals, and they have these pads, these really hard pads, and you have them too in your body, at certain places under your toes, and man, this thing is a monster. This was the end. This is where the blood came in. This side here was the vein side. You see the black? Oh! You see the black right there? They don't do that. They don't turn black like that normally, ever. What you end up with is two little black spots that just stay there. This forced the vein blood out. Absolutely unheard of. And you see this? This is that squeaky little stuff that you have between your big toe and the other toe. That's what it is. It's a little scruffy looking skin. All right, see? Now, on the other side is the callus side. And on the top, right here, you see that? Let me see if I can straighten it up. Okay. All right. You see that? That's the toenail. Came right up to here. And that's the callus. All right, and that's the front of the guy's toe. Right here. And it seams right across here. I don't know why they do that. And underneath was that fibrin stuff that I showed before. And that's the scruffy little stuff that goes along your other toe. And this is where it blew out. The vein blood, and that is just unheard of. All right, there's your toenail. And they turn like this, and then they eventually will turn like this, all silvery and metally. Because this thing is hard, heavy. And then they will eventually sublimate down to this and transition down to this. And you'll end up with that. That's that little bony spot that's in the back. I'm telling you, I've seen, and I got a bunch of them. That, I mean, all the little tiny ones will do it too. I got tons of these. You'll find them. You just look around and see all of this stuff you'll see. And if you're lucky, you will see a duck or a goose, like I did. You see this? It's a goose. The goose's head. You see the feathers? Look at the feather pattern on the top. Well, I suppose I can do the same thing here. Turn it this way. See it? There's the feathers on the top of the goose head. That's a goose. Right, there's a little scruffy stuff under their goose's neck. They look like that. He was laying sideways. This is... He died like this. Laying like this. That's his neck coming around. That right there is his neck. And right above it is the bone. Alright, this is Mudfossils.com, and it comes to Mudfossil University, and it's under construction right now, the website. It's been, this is my research, and this brings you to the DNA reports, and all three of them, the three things that I just talked about, the mud tip, the lung, and the 36-inch tip. 36-inch tip was the big skin thing. the lung, which is the lung, and then the mud tip was the one that wasn't quite as dense. But you can come up here and look at it, and they all came out with positive results. The two of them were very dense, and one was not quite as dense. But they all came back with the Homo sapien mitochondrial cytochrome B gene and mitochondrial D loop region. So come up to Mudfossil University on YouTube. Alright, and this, you can come up here, and there's all kinds of stuff up here about our ancient past and about our history and about the earth and about the rocks and about the KT boundary and energy, health. Mudfossil University on YouTube. Subscribe, ring the bell, spread the word. Alright, thank you.